Hey folks, welcome to my channel Number Pen. So in this video, we're going to look at Bernoullis integration by parts, right? So in my previous two videos, we would have solved problems where I had to apply integration by parts successively, right? So for example, one of the problems that we solved was integral of x square cos x dx, right? So we had to solve that by applying integration by parts twice. So in this particular video, we're going to generalize this, for problems where we will have to apply integration by parts successively. And what we're going to see is an identity which we call as Bernoullis integration by parts, right? So we're going to look at a quick and a simple derivation of this particular identity. So I know my integral by parts tells me that integral of u dv equals uv minus integral of v du, right? Now I know that I can rewrite my du as du by dx into dx, right? Now when you observe the second part of the RHS, and let me highlight it in a different color, say green, I notice that I have a du by dx, right? So I know that my du by dx is nothing but u dashed, right? Where the dash tells me that it's the first derivative of u, right? So let us write down that my du by dx is nothing but u dashed, okay? And then I have my v dx within that green expression, right? So I'm going to go back to this particular integral by parts and rewrite this using u dashed, right? So my first part is integral of u dv remains as it is, and then I have my uv. Then the green expression becomes integral of u dash times v dx, right? This is what I get. When I apply integral by parts again to this particular expression, and let me again highlight it in green. Now, for the sake of applying integral by parts to the green expression, I'm going to rewrite the basic integral by parts not using u dv, but I'm going to use f and g, right? And let's write this using f and g, right? If f and g are two differentiable functions, then my integral of f dg equals fg minus integral of g df, right? Now, the reason I wrote this using f and g is because I'm going to apply integral by parts again to the green expression, right? So now, what is my f? My f is nothing but u dashed, okay? And what is my dg? My dg is nothing but v dx, right? I have my f, I have my dg, I need my df. I know my df by dx equals d by dx of u dashed, right? Which means it is a u double dashed, okay? I hope you folks are with me. And which means my df equal to u double dash times dx, right? Now, here is where I want you folks to look at this closely, right? My dg equals v dx, right? So what is my g? My g is nothing but integral of v dx, right? And what is it? My integral of v dx, I know that I will have my v, my integral of v dx, I'm going to call it as v1, right? Where my v1 is nothing but the successive integral of v with respect to x, right? So again, I'm repeating this. When my dg equals v dx, right? Let me highlight it using a different color. When my dg equals v dx, my g is integral of v dx, and which is what I'm calling it as a v1, which is my successive integral of v, right? I can call it the first successive integral of v, right? So now when you look at this, right, I have my f, I have my g, I have my df. Write down what is my fg. what is my f? My f is u dashed. And what is my g? My g is v1, right? And what is your v1? It is the first successive integral of v. Okay. And then I have a minus of integral of what is my g? My g is v1, so I write it as it is. And then I have my df, right? What is my df? Is nothing but u double dashed times dx, right? So now I go back to my udv expression, right? My udv expression is nothing but uv minus integral of u dashed v dx, right? And integral of u dashed v dx is what we did in our previous step using the integral of f dg. And what we arrived at is u dashed into v1 minus integral of v1 into u double dashed dx, right? So I'm going to open my bracket here and I'm going to write it like this, right? Now, when I expand this, what do I get? uv minus u dashed into v1, where remember that v1 is the successive integral of v, the first successive integral. And then I have a plus now, and I have a plus integral of v1 into u double dashed dx, right? This is my integral of u dv, right? So this is where I am. And imagine if this particular expression, right, let me highlight it this time again in a different color, say turquoise. If the expression in turquoise, I will have to again apply integral by parts, right? What do we get? Now, I'm not going to work this out again for you, and I want you to draw a parallel to what we did in our previous step using integral of f dg, right? So I'm going to write it using what we solved for under integral of f dg, okay? So what happens to integral of v1 into u double dashed, right? Folks, I want you to observe this very closely. In my previous step, right, I had integral of u dashed into v dx, right, which is what we solved for. So take a look at what I've highlighted in green. Integral of u dashed into v dx equal to u dashed v1 minus integral of v1 into u double dashed dx, right? And now in place of v, we have v1, and in place of u dashed, we have u double dashed, right? So wherever we have a u dashed, make it a u double dashed, okay? And wherever we have a v1, you will have to make it a v2, right? So v2 is the second successive integral of v, okay? So what happens in place of a u dashed v1, I get a u double dashed v2, right? I hope you folks are with me. And in case you've not understood what I'm trying to do, please do mention in the comments. I'll be happy to help you out, right? And then again, I have a minus here, okay? Integral of v1, remember wherever I have a v1, this time it becomes a v2, right? And instead of a u double dashed, I will have a u triple dashed, okay? I hope you folks are with me. Wherever I have a u dashed, it becomes a u double dashed, and wherever I have a v1, it becomes a v2, and wherever I have a u double dashed, it becomes a u triple dashed, right? And you folks can try working this out once again using the integral by parts. So this is what I get, right? Now I go back again to my udv, right? And I'm going to expand this using whatever I have written down just now, right? So my integral of udv is equal to uv minus u dash of v1 plus, now my integral of v1 into u double dash dx becomes, right, u double dash into v2 minus integral of v2 into u triple dashed, right? So this is what we get, right? So this way I can go on expanding, right? I can go on expanding till this integral term, let me highlight it in a different color, say pink, becomes 0, right? So integral of u dv equal to ub minus u dashed v1 plus u double dashed v2 minus integral of v2 into u triple dashed dx, right? So where u dashed, u double dashed, and u triple dashed are the first, second, and third derivatives, and v1 and v2 are the first and second successive integrals of v, right? So I hope you folks are with me, and this is what we call as the Bernoullis identity of integral by parts, right? And for your sake, I'm going to expand this one more time. Integral of u dv. Now, if I expand it one more time, I get a uv minus u dashed into v1 plus a u double dashed into v2. Okay. And then this time I will get a negative sign. So I will have a u triple dash times v3. Okay. And then I have a plus sign now, v3 times fourth derivative of u times dx, right? And this is how we go on expanding using integral by parts until the integral expression what I have towards the end of my RHS becomes 0, right? So this is what we mean by Bernoulli's identity of integral by parts. And in our subsequent video, instead of going step by step using integral by parts, I'm going to directly apply this particular identity and solve the problem, right? I hope you found this content useful. Please do subscribe to my channel and support.